We're going to pick up on page 11 of sine and cosine, and it'd be nice if it always stayed plain old just y equals sine x or y equals cosine x, but it doesn't. The graphs get moved around, they get stretched, they get moved up, down, left, and right, so we're going to learn how to do that and how to tell what kind of graph it is. So the first one on page 11 we want to know, is each of these a sine graph or a cosine graph? Now it's hard to tell from looking at them because they're the same shape, because sine and cosine are the same shape, but we have ways to differentiate. So my first piece of advice is look at the y-intercept. If the y-intercept is a maximum point on the graph or a minimum point on the graph, if it's at its high point, or low point, then it's cosine. If the y-intercept is a middle point, then it's sine. So if we look at this graph and we go to our y-intercept, that y-intercept is a maximum point. So if we said if the y-intercept is a max or a min, then it's cosine, then this graph is a cosine graph. Do we know the exact equation? Not yet, but we're going to learn that. If we look at this graph and we go to the y-intercept where the graph hits the y-axis, it hits it in the middle. It's not at its high point, it's not at its low point, it's somewhere in the middle. That means this is a sine graph. Do we know the exact equation? Not yet, but we'll get there. So when we have sine and cosine equations, we really look at y equals a sine bx plus c, or y equals a cosine bx plus c, where we can have coefficients of sine and x, or coefficients of cosine and x, and then add on an extra number at the end. Well, these coefficients all have meaning, and they each do something different to the graph. The first thing we're going to look at is the amplitude. The amplitude is what we call the distance from the midline to the max or the min. Okay, the amplitude is also equal to the maximum value minus the minimum value over 2. So now for each of these, we want to graph sines, and these are both sine examples, sines that don't have an amplitude of 1. They have an amplitude of, in this case, 3, or in this case, 1/2. And the amplitude is the absolute value of a. So if a is negative, then the amplitude is just the positive of it, because the amplitude is the distance. So in this one, we have a equals 3. Now the way I like to do my trig graphs is I say, okay, sine x. And what we have to remember about sine x are our quadrantal angle values, our 5 values, 0, 1, 0, -1, 0. Because remember, that's our 0 degrees, our 90, 180, 270, and 360. Once we have that written down, because it's a sine graph, and we have those 5 values, then we take those 5 values and we multiply them by our a value. So now it's 0, 3, 0, -3, 0. And that's what we're going to be graphing. So if we go up here, we're going to label the way we did the other day, 90, 180, 270, and 360. And we need to go 3 and -3. So 0, 3, 0, -3, and 0. And when we connect, it's a curve. It's not sharp points. It's a curve. And we label it y equals 3 sine x. Now, why don't you guys try the 1/2 sine x on your own? Okay. The next thing we're going to look at is the shift. So remember, we have y equals a sine bx plus c. And we already said a was the amplitude. The shift is the c value, and it's a vertical shift. Every point on the graph moves up or down c units. So here we go again. We have y equals 2 sine x plus 1. Again, start off, it's sine. So for sine, my numbers are 0, 1, 0, -1, 0. Go with my 0 degrees, 90, 180, 270, and 360. First thing we do, we take those, we have an a value here. We have a equals 2, and we have c equals 1. So first, we multiply our 5 values by a. So multiply by 2, we get 0, 2, 0, -2, 0. Then our second step is we add c to those 5 values. So we have 1, 1, 1, 1, 1, add them up. 0 plus 1 is 1, 2 plus 1 is 3, 1, -1, and 1. And now we can graph like we did before, 90, 180, 270, and 360. And 1, 2, 3, -1, -2, -3. So we're at 1, we're at 3, we're back at 1, we're down at -1, and we're back at 1. And there's our sine, or 2 sine x plus 1 graph. Our regular sine graph would look, 0, would look like this. This is a sine graph that got stretched out a little bit and got moved up. Okay, so the a stretches it out, it's a dilation, and the c moves it up. So a is a dilation, and c is a translation. Okay, so now you guys try 2 sine x minus 1. Doing the same thing we did over here. Start with your 5 values, multiply by a, and then add c.